Hello everyone, we are back again with part 13 of the chapter Light, Reflection and Refraction. And in this video, we'll talk about refraction of light through a glass slab. So let's understand what exactly happened when light passes through a glass slab. So before we go ahead, I want to tell you that in the previous video, we have discussed that whenever light passes through, called as lateral displacement. From this end, it should have gone here, but it is going this way. This is lateral displacement. That's what happened when light passes from uh, air to a glass slab and coming back to air. So let's basically understand what exactly happened with the glass slab. So this is the overall titling of the concept of glass slab. We have a glass slab. You can see all the labels are represented here, and you will be seeing the ray of light. So this is incident ray of light, which is passing from air to glass surface, and this is the original path. So if there is no glass slab, light will pass this way. But because this is a glass slab, medium is changing, light is bending towards, and we observe that afterwards again from glass to air interface it is bending, and we observe there is displacement which is uh, parallel to the original path. You can see this is normal 1, normal 2, and these are the remaining labeling: angle of incidence, angle of reflection for air to glass surface. We can see next angle of uh, okay, yes, angle of incidence, angle of reflection, and next we can see is this is basically angle of refraction for glass air interface, but because light is going outward, so it is moving out of this glass slab, so we call it as angle of emergence. We represent it with symbol E, and this is angle of emergence, and we can see this is the displacement. We also call it as lateral displacement from the original path. And you can see what happened when a ray of light passes through a rectangular glass slab. It gets bent twice. We observe where it is twice, once here, and second time it's at this end, and the emergent ray is parallel to the incident ray and displaced through a distance. You can see this is the original path, and this is the emergent ray. This is basically refracted ray for glass air interface, and because it's going out of the glass slab, we call it as emergent ray, and angle made by emerging ray with the angle with the normal is called as angle of emergence. So now where do we use this concept? We in daily life we observe that when we go for fishing, we usually find that fishes appears to be raised, whereas they are not basically. And we can observe with this concept, you can actually place a small uh, straw or a pencil also inside a glass of water, transparent glass, and you when you observe from the top, you will observe that the pencil appears to be bent, which is ideally not bent, but because of the refraction of light we feel it's bent. Also, the concept here is the real depth and apparent depth. The depth which where the object is actually lying from the surface is called as real depth. It's the actual distance from of an object beneath the surface as we would measure the submerging object, and the real depth is that is the actual depth, and apparent depth is a depth which where the object is appearing to us from the top. So that is the apparent depth. And if you observe, there's a formula also, although this is not included in the CBSE grade 10 syllabus, but there's no harm in learning extra. The formula goes like this: if you want to find out what exactly is the apparent depth, then you should know the real depth of the object, where is the object kept in the real situation, and what is the refractive index of the water if it is kept inside the water. The next video will be discussing about what is refractive index and how it is related to light passing from one medium to another medium. I hope you have learned something from this video. If you have any question, do put it in the comment box. In the meantime, thank you and have a great time. Bye bye.